Yeah, my talk is about data at Big Chemistry and how we're using NOMAD. I think first I need to introduce who Big Chemistry are. So some of you who were at the panel session yesterday, I gave a brief overview of what we're doing, but I've got a bit more time now to go into a bit more detail. So starting off in terms of some background information, we are funded by the National Growth Fund in the Netherlands. Originally, the project was called Self-Thinking Molecular Systems, and it's funded until 2030. So we received the funding at the end of 2023 for 97 million euros for the Growth Fund. And at the moment, we have over 50 PhDs and postdocs within the consortia, with 25 PIs spread across 5 research institutes. So the research institutes, Technical University of Eindhoven, Amhof, Radboud, Rijksuniversiteit Groningen, Fontys Hogeschool, which is the University of Applied Sciences. And then in addition to sort of the paid researchers, we also have potentially between 20 and 30, possibly up to 40 bachelor's and master's students participating in consortium research activities. And the aim for the consortium is developing the tools for the next generation of the chemical industry. So what this means is we're looking at using artificial intelligence and also creating self-driving labs to accelerate the development of formulations in industry. So formulations is a big topic. In terms of the actual science we're looking at doing, we've got 3 big topics that we're mainly focused on. The first one is films, foams, and emulsions. The second is peptides, proteins, and condensates. The third is catalysis and chirality. So this is roughly the 3 main research areas all our research projects fit into. There's a 4th sort of other category, which also includes all the IT infrastructure and what is required to support the consortia, which is a secondary research aim to support this primary science. And that's more of what I'm going to be talking about today. One, I think, important note is we are National Growth Fund funded in the Netherlands rather than National Research Council. So that means we need to valorize our research for post-2030 sustainability. And part of our aim of the consortia is also to have an impact on the Dutch national economy. So this is where valorization is a core part of our consortium. So the idea is we're going to be using the power of data-driven chemistry to accelerate the discovery of next-generation sustainable formulations. So I've just put a few example formulations. In the current sort of target market segments, we're aiming to have the impact in first. So that's personal and home care, paints, coatings, inks and adhesives, pharma, small molecular entities, and also food. So here's the representative selection of different formulations you may have come across in your everyday life. So this is where we're aiming to have an impact in terms of the formulation science. So now we'll have a look at why have we chosen NOMAD. So given the fact that we are a multi-institute research consortia spread across the Netherlands and also have commercial aims, that means we have some ideologically very different data requirements, but technologically they should be able to be solved with the same tool set. So this gives us our requirements. So from an academic point of view, we very much like open science and fair data, and we want to be able to have open collaborations with our academic partners and also other academic groups. And this means for this type of work, we need broader user access. And we have multiple diverse data sets in different fields across the entire research interest of the consortia. So we need a relatively open and flexible and customizable platform for that. From a commercial standpoint, industrial partners often have strict confidentiality requirements, so we're not able to share everything with everyone. So that means data should be able to be compartmentalized with restricted user access. But also these companies don't want access to all the information we have. They only want access to specific segments related to their specific market area. So this provides 2 ideologically different ways for how we should be handling data, but hopefully the technological stack below can handle both. And this is why we move towards looking at NOMAD as a technological solution for both of these problems. So in terms of the research data management vision, this was one of the first pieces of work I did when I started at the consortium. So the aim of our work is to be able to support both the academic consortium members and also current and future commercial operations. So this is sort of very key. We've got to be able to do both. So as part of that, NOMAD Oasis provides a research data management platform we have control over. So this means we can both do horizontal scaling. So we create more Oasis instances, different use cases, but we can also go vertically and create larger instances if there's more users using a particular one. And also, because of our aims, the long-term data access management and cybersecurity are critical for big chemistry. So having controlled access to the data is essential for our long-term sustainability as a consortium. If we want to be funding new academic projects beyond 2030, we have to be able to successfully valorize current projects. So we generate enough revenue to be able to pay for central big chemistry and generate some profit that can be used to pay for new studentships. So as part of that, alongside Will Robinson, who's one of the senior group leaders in Radboud and a coordinator of the consortium, and in discussion with the wider consortium partners, we came up with this grand vision that we are in the process of trying to implement. So the idea is the user, typically the research scientist at the moment, so the PhD student or postdoc, will be doing experiments in their lab and generating the data locally. And they will be using some form of electronic lab notebook to record their experiments. And then we will be depositing all the data they're gathering into NOMAD as a sort of central user platform. However, we're going to be doing it initially at a sort of per institute basis. So this gives us some separation already. And then from the institutional OACs, we will then be able to synchronize the data and transfer it to a central big chemistry OASIS. And then in the future, as we get companies interested in portions of the data, we would be able to create new instances which we can restrict access just to their users to be able to serve data to them. So this provides us the ability, this is why we're looking at NOMAD Oasis as a platform that we can scale and have multiple instances running at the same time, each with distinct user groups. So that leads us on from this vision to our deployment requirements. So we want to be able to have a multi-OASIS system that we have access controls over. So the OASIS are private by default, but as we're also interested in doing open science, it could be in the future we have a public OASIS for data that we want to share publicly with the community as a whole. We also want unique user groups. So this means one user group per OASIS. We also want our own key cloak, so IAM service, Identity and Authentication Management Service, so we can control who can log in directly rather than going through a third party. Also, what's critical is we want a system that should have easy maintenance. At the moment, I'm the only person employed by the central consortium within any expertise domain of data and IT. There are some researchers within the different institutions that are employed for these purposes, but it's rather decentralized at the moment, and that's something we're looking at growing the team. But it's always going to be significantly smaller than the number of researchers we have. So we want something that can be managed by a couple of people as needed. And we also want to ensure we can support ELN integration into whatever data management solution we provide. So this is why NOMAD is useful in terms of the definition of schema. So we can look at integrating data we generate from within either Commotion or eLab FTW, which were chosen to support researchers in consortia. So this is a bit of a background in terms of why we've moved towards Nomad as a solution. I think the more interesting part for the people in this audience here today is how have we gone about implementing NOMAD Oasis and what are the technological challenges we've come across. So I want to start off with sort of the basic infrastructure architecture. So this vision makes a very nice picture for presentations and presenting to the board, but it has absolutely no understanding of the feasibility of the required architecture. So there's no understanding here of how do you actually implement it. So this is something where researchers within Fontis, one of the partners within our consortia, gave me a lot of help. And I want to highlight sort of Norbert, who's one of the project students who worked on this, looking at the initial proof of concept architecture design. So this is looking at how to handle all the networking below this and how do we look at where are we going to be running the compute power, how is the compute going to be organized and all of that. They started with the initial design. We then moved on to the production environment design after this proof of concept, which was refined and implemented by SLTN, a consultancy company that we've been working with. And part of these two phases has been incorporating security by design concepts. So this is something, since we're wanting to work with companies that may want to keep data confidentially, we have to be concerned about how people are accessing data we control and making sure only the right people can access it. And if someone were to try something malicious with our setup, we also have to be able to deal with that and recover from any failures. So this also fed into the decision in terms of initial maintenance, where we were looking at using Terraform as infrastructure as code to make it easier for deployment of resources. We also initially made the choice of AWS for hosting, Amazon Web Service. This is partly because at present, the consortium does not have a physical location. So we have no location where we could host our own hardware to run the servers. So this is why we initially chose cloud. And it's something we could have looked at hosting some things in partners, but we had no idea of the scale of compute we would require and how quickly we would outgrow that. So this also provides us a chance to scale and figure out how much we need, both in terms of compute and storage. And it helps that AWS is one of the platforms used in teaching within Fontis. So that way we get access to a lot of bright infrastructure, IT software students and cybersecurity students that understand how the platform works. So in terms of the actual running, so the architecture we've gone for is we're wanting to use Kubernetes as the compute resource management. So the idea is, and this is something that Laurie touched on in his session yesterday for hosting Nomad, the idea is Kubernetes provides greater scalability and robustness than Docker, particularly some of the self-healing nature and the ability to scale up to have more pods running, so you have more copies of your core components containers running. So this provides that scalability we require if we have lots of users using the same OASIS, and this could be variable depending on time. And also, if we're looking at the self-driving labs we're creating, we could be having machines writing directly to the OASIS in automated pipelines. So we have to be preparing now for a future where we could be scaling to 10, 100, maybe 1,000 times the amount of data going through these pieces of infrastructure. So I think the other important thing is Kubernetes namespaces allow different resources to run on the same cluster, but with partitioning. So this means only certain resources can see that the other thing is running on the cluster. So this way we can have our key cloak instance in one namespace, Nomad namespace 1 for the first Oasis, Nomad namespace 2 for the second Oasis, and so on. So this gives us the greatest flexibility to expand how many Nomad instances we are running on the same piece of hardware. And it's also something that the cluster itself can scale its size as we increase the resource demand. So as part of that, we're using the sort of EKS, which is the Amazon managed Kubernetes deployment. And the actual cluster deployment phase can also be managed by Terraform. So this means for me, it's click a few buttons, run this configuration file, apply it to Amazon, and all the resources are deployed in a few minutes. It actually takes sort of 20 minutes for the cluster to start and everything else to be deployed, but it's, for me, a couple of clicks and done. So that's very nice. The second sort of technological part is Keycloak. So this is the user management system. So the idea is we want to be able to configure different user groups individually. So the idea is we have to be able to control access to each NOMAD Oasis individually, unlike the central NOMAD installation where you have one main user group for all the Oases that are being run. We want to be able to control each NOMAD Oasis user group individually. So that's part of the reason why we wanted to have our own Keycloak running for authentication purposes. And then we also split it up so each Keycloak has its own realm. Each realm in Keycloak is for a different NOMAD Oasis. So this way we have Keycloak 1 centrally running, and there's realm 1 for Oasis 1, realm 2 for Oasis 2, etc. And this is something we can keep expanding. The other benefit is Keycloak can also be run on Kubernetes, so it can be using the same infrastructure there. And also that means it's available to be deployed alongside Nomad and run also in high availability. So for those not familiar, high availability means that you have different regions or availability zones where your code can run. And what happens in the high availability circumstances, if one availability goes down, it defaults to a different availability zone. So this way you maintain service uptime significantly higher and for longer. So this is particularly important if we are working with industrial companies that may not be as forgiving as an academic research group where if a service goes down for a day, they're okay with it. So we're also looking at supporting researchers for onboarding through the use of Surf Connects, which is a service provided by the Dutch Central National Educational sort of research IT infrastructure provider, SURF. So that should hopefully make user onboarding in terms of the academic researchers more streamlined. So now we move on to the NOMAD Oasis deployment challenges. So for us, we started with this vision sort of March last year, and then we started doing the proof of concepts work in September, October, November. And then we started looking at moving towards production, and that work started in December. And then in January, February, we were deploying the base infrastructure layer and getting all of that ready. And then we started working on Nomad deployment. And this is where in sort of February, March this year, we started investigating Nomad with the SLTN team. And what was also happening at this time was the Nomad team were actively transitioning from using RabbitMQ to Temporal as the back end for workflow management. So that meant the previous Helm chart that was used was now out of date, and there were lots of dependencies left there. So there were also several manual steps involved in the Helm deployment, which is okay if you're wanting to set up maybe 1 or 2 instances, but because we were thinking initially we're looking at least 6 NOMAD Oasis instances we're wanting to deploy at the same time, possibly going into double digits quite easily. We want a much more automated process, a much easier process to manage, to be able to deploy multiple Oases in sort of 5-10 minutes at a time, and then let the compute take care of the rest of it. It's also important to note at this stage as well, it was incompatible with both the Amazon EKS clusters and also the storage options for where all the files would be deposited at this initial stage. So this meant we needed to do quite a bit of work alongside the NOMAD team on updating and improving the Helm charts so we could make better use of the AWS resources we wanted to deploy on. So this is where I want to highlight Maria Dinkova, who was the lead developer at SLTN that took on most of this work on behalf of Big Chemistry. And I know that Amir and Laurie have had several emails back and forth with her about all the configuration problems we came across during this development. So just to highlight some of the pieces of development we were involved in, we can now deploy on AWS, which is a big win for us, and also something that anyone else that wants to deploy on AWS, it should work now. Also, as part of this, we've looked at improving the flexibility, exposing hard-coded values in the original Helm charts and allowing different configuration per provider. So it's making the Helm chart much more flexible. So you can have more configuration done at the Helm chart level and less is sort of intrinsically baked into NOMAD itself. So exposing some of that underlying functionality at a higher level. We've also done some dynamic updates on the probes to allow more flexible management of the startup when plugins are used. So this is something where when you launch workloads on Kubernetes, there are probes testing, is the container running? And this is something for certain containers, particularly I think the application itself, it can take anywhere from 5 to 20 minutes to start. So this is something where the original probes for detecting, is it still starting up? Is it healthy? Were failing because it was testing too frequently at the start. And that is a function of how many plugins are installed in the application. So when you have no plugins, the deployment time for when you set it up running on Kubernetes cluster are very straightforward. We also enabled persistent storage and also per volume control. So you can change where you're storing the data and modifying that. Additional security hardening, and also the refactoring the Helm code after each NOMAD Oasis version update. So this was also something, as we were testing the latest releases, we were also looking at how that breaks the Helm chart and then providing feedback on updating that. So in terms of our outlook on the future, we have our NOMAD platforms now available. We now have to onboard researchers. So we're approaching first contact with researchers to make sure they can upload their data. So this is where we're now exploring the existing plugins and schema available for compatibility with our data needs and looking at the design process for future plugins we may need to build. We're going to be looking more at the further refinement of the Kubernetes deployment with Helm and explore the possibility for high availability deployments. In addition to further work on security and monitoring, and also we're looking at getting more involved in the testing of new releases to make sure Helm charts still function with new versions. So now we've got this infrastructure in place and our own testing area for Oasis, we can hopefully contribute to further developments within the community and act as a test location for Helm releases of NOMAD. So in terms of acknowledgements, these are the main consortium members and the ones I've been working with and provided some information for the initial slides. So Cusco Francesco Aldo, for the business developers and managing director of the consortium in this picture here. Will, who I mentioned earlier, he's one of the group leaders in Red Valves. Firas and Norbert, who did work on the initial prototype. The rest of the consortium members, the SLTN team, particularly Maria. Also the NOMAD team, particularly Laurie and Amir, for being open for communication. And that's it from my side.